Thank you for having me. It's exciting to be here. It's a little early in my time zone, but it's all good because I love teaching and I love teaching students and I love teaching developers and helping developers get started. So thank you for the background about myself. Just to go a little bit deeper, what I did in the military was a computer networking engineer. I go out in the middle of nowhere, shoot up to a satellite, grab an uplink, and deploy a network. And then after that, I went to work for a huge United Health Group healthcare company. And worked as an entrepreneur, like you mentioned, so building healthcare startups. And then ultimately, what we did was we ran into these emerging technologies really disrupting healthcare and other industries and sectors. So, you know, if you think about when the internet came out, a lot of businesses are thinking, well, what is this internet? Why do we care? How's it applicable to us? What's this thing called a web page? Do we need a web page? Nah, we don't need a web page. Web pages are a fad. The internet's a fad. It's not going to be here. These are some of the things that new technologies put in people's minds. They don't understand, the businesses don't understand how to leverage these technologies. And so we created a group specifically called the Advanced Technology Collaborative that was solely focused on applying these emerging technologies in the healthcare space. So those technologies could be blockchain technologies, AI technologies with computer vision, natural language processing, machine learning, deep learning. You know, the list goes on for AI, natural language. Yeah, it's a quite extensive list. Graph database technologies, quantum computing. So these are a lot of different areas that our group focused in on. I specifically came from the networking world, so I went back into developing graphs and that's sort of where my journey started with graph engineering. And it was eye-opening. It was a paradigm shift in how we're able to access all this data across a lot of different fields and different systems. And so what we're going to do is do a little bit of a deep dive into that use case that I was involved in. And then ultimately what happened was I got recruited by Tigergraph and ended up over there. But while I was at the Advanced Technology Collaborative where we built out these emerging technology use cases, I started a nonprofit called Futurist Academy that was really sole focus was to bring these emerging technologies to schools because there's a huge gap. You know, it's not like the teachers are in the classroom teaching you about blockchain technologies or how to build robotics. Or computer vision applications or graph use cases. And so what we wanted to do is bring these emerging technologies to the students. So thank you so much for having me here today. And with that, let's get started. So before I get into my talk, sometimes it's fun to actually get hands-on and do stuff. So I wanted to at least get us hands-on during this talk so we can actually have something at the end of this. If we have enough time, we'll actually do a deeper dive into the cloud portal. But at this time, if you want to actually participate and have your own graph solution with a few clicks, it's just going to be pretty easy to provision. Go to https://tgcloud.io, and what you'll want to do is create an account. So we'll just get out of here for a second. And we'll go over to this cloud portal before I start my talk, because what we have to do is you have to verify your email, and then what we'll do is spin up a Box instance. So if you went to tgcloud.io, what you want to do is sign up. So log in or sign up, go to sign up. If you have Google or LinkedIn, feel free to use one of those. I have an account, so I'm just going to sign in. And then once you sign in, you should land in here. So at this point, I'm going to let you create your account, get into this where you see this screen, and then we'll jump back to the deck, and then we'll come back here again to provision a box because it takes about 5 minutes for the box to be provisioned. So hopefully at the end of the talk, what we can do is do a deep dive on some of the technicals of the platform itself. So we'll go back here. All right. So I see that we have like an emoji thing in this room. So I think we should try to use it. So how many people here know what graph databases are and how they're used? If you do, put your hand up. Awesome. We have 1, 2, 3, 4, 5. So 6, 7, 8. I don't know if that's a disappointed look as I don't know yet, and we're going to find out. Awesome. Well, I see a few. I see a few. So we have about 7 out of 354 people here. So hopefully by the end of this, everybody will have a little bit of better understanding about what graph databases are, how they're being used, and then not only have that knowledge, but you'll have hands-on knowledge that you can actually use these things. So what if I told you you are using graph databases multiple times throughout your day? You might be thinking, well, what? I'm not touching these things. I've never even heard of this technology. How am I using this every day? So we'll go into some use cases that you're actually using this under the hood without you even knowing it. So today we're going to talk about what are graph databases, why use graph databases, and where are they being used. All right, so I put another little thing in here. So at this point, hopefully you verified your account. And what we're going to do is go through and provision a box before we go through the rest of the presentation, because this does take about 5 minutes. And what I wanted to do was make sure you have a box available by the time this workshop is over. So hopefully you went through and provisioned, you know, got an account. So then you verified your email. And then what you should do is you should land into this page right here. What we're going to do is move to My Solutions, and the My Solutions tab is where you can provision a box. So we have all of these boxes I've provisioned in the past. I've terminated them. TG Cloud allows you to have a free box. You can do whatever you want with it. It's available on the internet, so you can access it anywhere in the world. And we'll go through the steps of provisioning this box. So you logged in, you went to My Solutions. We're going to go to Create Solution. And here's where you can choose your Tigergraph version. We have a bunch of starter kits that can get you started. So these are some of the use cases we will talk about today. This allows you to instantly be able to just sort of choose one that you're interested in. Let's say I want to look at COVID analysis, or maybe I want to just understand GSQL, which is our programming language. Maybe you want to see how graph databases are used in fraud or money laundering. Maybe you want to just see how it's used in healthcare, or maybe you want to use, learn how the graphs are used in social networks. And we'll do a little bit of deep dive in social networks and how graphs are being used in the back end throughout this talk. But what we'll do for this workshop is we'll just choose the COVID-19 analysis, and we'll just click next. So if you are just logging in the portal, go to My Solutions. There was a button at the top to provision a solution, then go to COVID-19, click next. Now the box, you get AWS or Azure. We're going to go AWS because we're going to have the free instance. So we're going to do AWS. We're going to go free. You can move, the region that the box is provisioned in. I'm just going to leave everything the same. After that, just click next. So I didn't touch anything. I'm just going to click next. Now you get to name your solution. So, this is my COVID kit. So maybe I'm going to just do my last name -COVID. And, once we get down to this subdomain, everyone wants to be unique. So don't copy my name for the address, because everybody's going to have a unique address. So you can take your solution any way you want. I'm going to just set a password. Don't forget your password, because if you want to use, you want to be able to access this box, you'll need your password at some point. Now here, your custom subdomain. Now this allows you to literally, log into your cloud or your box that we're provisioning anywhere in the world. You want it to be unique, so do not use the same one I'm going to be using. Otherwise, we're going to have some issues. And then once you do that, click next. And then that's it. That's literally all you had to do. So the only things you had to do is pick your kit, click the next button, give it some details, and then click submit. And at this point, it'll provision the box. So you'll see that the new box is being spun up. It'll take about 5 minutes. They say grab a cup of coffee while you're waiting, but what we're going to do is go back into our talk. So if you have any questions, throw them in the chat. I'll try to answer them as I go through the talk here. But let's go back. All right. So what are graph databases? You might be thinking, what are graph databases? And hopefully we'll answer that today. So you might be familiar with some of these, right? I'm assuming everybody here understands relational databases, primary keys, foreign keys. You have a bunch of tables, and you have these tables that are connected. And then if you want to, access data across these different tables, you simply just join them up. So they have a very rigid schema. They're high performance, really high performance for transactions, but poor performance for deep link analysis. So let's say you want to have, there's data over here, 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 and you want to pull that stuff together to find those analytics. It gets a little bit complex. Now we have key value store. Or key value databases, highly fluid. There's really no schema, high performance for simple transactions, but poor performance for deep analytics. And then we get into graph databases. So the thing that makes graph databases unique is you have this really flexible schema. So let's say you need to append new data onto your database. It's pretty simple. It's very high performance for complex transactions, and you can also perform those deep link analysis. So this is just a little bit, a relational versus a graph. You have relational, you have these rows. They're the atomic units. On the right-hand side, you have these nodes and edges. You have sort of a fixed structure on the left. On the right, you have the ability to add new elements to it. What you can do instead of on the left, you have where you have to join tables. On the right for graphs, it's simply you're just accessing the memory pointers. Which allows you to hop through the data pretty fast. So it's all about like the modeling of the data to access certain elements, and we'll go into that in a little bit here. So what's sort of the schema look like? This is a simplified schema. I have an order, I have a payment. The order can have attributes, so the vertices, the vertex, or some people might say the nodes. The node edges themselves, and then you can have the other node on the other side, the vertex on the other side that has additional attributes as well. So this is called a label property graph, and that's what we're going to be talking a little bit about today. So why use graph databases? Well, there's no really penalty for modeling complexity. So once you have, as we're talking about, you have all of these tables, and you want to bring things together. Maybe you have to add something new. Then you have to redesign the schema, and it's very cumbersome. But when you're doing graphs, you have no penalty for actually the complexity of the graph itself. Simply, if you need to be more efficient, maybe you just draw an edge from one vertex to the other. And sometimes you'll have to actually do this when you're running queries to speed things up. Because instead of doing multi-hops every time to get to the same one, you might want to just have a relationship that node. If you're struggling from death from joins, I don't know if this is a coin term, but I think it's prevalent in different industries. You're trying to pull all this data together, and you're sitting there and trying to access these things from different fields, and it's really cumbersome. But in a graph database, it's really not that hard to access those data elements. So you can simply write a query. When the data enters the graph databases, it's already pre-joined. So all your data is pre-joined. And it's just simply like a map, thinking about how you access the data that's in your database. If you're doing a lot of deep link analysis across your data, you might want to use graph. If you're looking for real-time aggregation across a lot of different data sources, you might want to use graph. You need flexibility, you might want to use graph. If you want to look at enhanced machine learning, I'm assuming a lot of people here have heard about machine learning. I'm not going to go into really a lot of deep use cases in machine learning, but I'll try to touch on some of them, how graph can actually enhance machine learning. So why are companies using graph? I have a little bit of a list here. So if you've heard of Wish or Jaguar Land Rover, HBO, Nike is another customer of Tigergraph. These are all customers of Tigergraph. Open Corporates, Intuit. They're all using it for a few different uses. Some of them are using it for fraud analysis and looking at the deep link transactions. So as you're a fraudster, maybe what you're trying to do is hide your path, right? You might be doing a transaction from here to 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 here. All these big companies, they have so highly complexible data, highly complex data across multiple systems. This is where I came from. So I worked at United Health Group. We have data across every single business, across every single system. We have claims over here, not just one type of claims. We have dental claims, vision claims, prescription claims. We have claims. In all these different businesses, we have all these different systems, these silos. We have patient data. We have call centers. We have facilities. We have prescribers. We have all of this information that people are touching the healthcare system with. Let's say a patient calls in and you want to pull that information together. Just imagine trying to pull all that information together across all of these systems in real time. In a traditional database, it would just be impossible. And that's where graphs really shine. So let's talk about how we would model that complexity. I broke it down a little bit here. So on the left-hand side is actually an open source healthcare model. So if you want to actually experiment with healthcare, I do have a project that you could spin up. And so we have a patient. A patient has a prescription. We have a start date. Maybe that patient started a prescription, but then had an end date for that prescription. So this is a just simplified model of how a vertice would be attached to another vertice and what the edge would look like between those two in the healthcare space. Maybe that patient also has an allergy, and then maybe they also have a claim. So what does this mean? What this means is that we can actually pull all of this information together in real time. So now that we have a patient and we have all of these different touch points and we have some data around them, let's go look at what we can do with it. So a lot of people think, oh, okay, graphs, they're just lines and dots, right? I think they get a bad rep because a lot of use cases, they show lines and dots, which isn't really, I'd say 95% of the time, it's not lines and dots. It actually looks a lot more like this. So we talked about a patient. So let's say we wanted to pull every single touch point that patient had within the healthcare system, every single touch point across all of the systems we talked about. We could do that. We could do that really easily, really fast. And when I say fast, it's 50 milliseconds. Imagine pulling all of that data together in 50 milliseconds. Just to give you a reference, Google search is about 200 milliseconds. So faster than a Google search, you have all of that data pulled together in real time, which just would be impossible. So it unlocks tremendous business value to the users, and you can pull all these touch points together. And these are just one of the use cases. You can also have a deeper understanding of your data. So you have these timelines and you have prescriptions and you have different ways to analyze that data. So we looked at the 360 view. Maybe we want to look at a different view of like a subcategory of patients. So maybe you do a patient similarity algorithm. We'll talk a little bit about algorithms in a little bit, but maybe you run a similarity algorithm, you determine similar patients, then you look at the prescriptions, and then you look at these cohorts, and then you look at effective treatment paths. So you can pull all this data together, run algorithms to have a deeper depth of understanding your data and your segmentations of all your data. So I guess I did have a little bit of a section that we can talk a little bit about machine learning here. So on the right-hand side, we have our data elements. We have, in this case, we have a provider, we have some claims, we have a patient, we have a claim, and then we have a provider. So we have this data that's going into the graph database. And then we have this orange line right here. This I don't know if you could see the mouse in this case, but on the right-hand side, you see an orange line on the right that says referred by. So that data element did not exist in the original data that was actually inserted into this graph or streamed into this graph. What they're doing is doing pattern matching to identify a pattern that would be indicative of a provider referring another provider. So a simplified version of this, let's say you have your graph and it's yourself and then your father and then there's another relationship to your father's father, right? So we have a person, we have a father, and then we have another father. But the graph or your data that you have, you don't actually have that your father's father is your grandfather. But what you can do is you know that pattern exists. So if your father's father, if your father has a father, which every father has a father, then you have that relationship as a grandfather. So you can infer, you can enrich your data with understanding your patterns and creating new data elements. You can also enrich your data using algorithms. And so you're looking at these patterns and doing algorithms to, in this case, they're doing community detection to define the communities of I think in this case, it's a medical community detection. So they're trying to find prescriber communities. And so you can use these data elements that in this case, they had to run an algorithm to determine some data about it. And so these new data elements that they compiled, they can use it for machine learning. They can use their enriched data for machine learning as well. We also, you can use text. So you could do traditional machine learning. Let's say you have, in this case, this is using, I think, SciSpacey or Spacey. So you do entity extraction, pull out the data elements, and then you want to semantically link it and then put it into your graph database. In the core sense of Google, this is what Google's doing in the background. Google has websites, and what they do is go through the website, they crawl through it, they process the website, they semantically link it inside of the website, and then they run an algorithm to determine what to show you. So in the very, 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 very simplified version, this is what Google's doing under the hood for you. So where are graph databases being used? On the left-hand side here, I have a bunch of use cases. We'll dive into those right now. So we talked a little bit about Customer 360 and recommendations. What I'm going to do is break this down a little bit to something I hope everybody is familiar with, LinkedIn. So I'm assuming most of you have LinkedIn or have heard of LinkedIn. And so what we're going to do is how LinkedIn is actually a graph underneath. So if you've used LinkedIn, you've probably used a graph. This is a person, myself. I have a lot of connections to other people. So how would I go about this? Let's say I want to create LinkedIn and I want to build the next social network. How would I deconstruct this and think about it in the way of modeling my graph? And that's what we'll do right now. So we have a person, right? We have a person that has an ID, a first name, and last name. And this is very simplified, so there's probably more attributes as well. We have a person that lives or is located into a city. And this is called a geotree here, a city, state, country, or province. You could label them however you want to label them, but having this linking between maybe an address or a city and a state and a country is called a geotree. So we'll insert a geotree here. We also have an organization. An organization might be located inside of a city. A person might work for an organization as well. And let's break this down. So now we have a post. So we have, in this case, Mohammed created a post. Myself liked the post, so we might want to capture that information as well. This post has tags. This post also mentions Tigergraph in this case. So you could start to see how the graph is starting to form by the different data elements that you might want to include in your use case. We also have a person follows a person and a person's connected to a person. So I might follow Mohammed or I might just send a connect request to Mohammed. So in both cases, maybe I'm connected and follow. And then we have groups. So groups, a person could be in a group. And then we have a person might attend an event. So you might have the event inside of your use case, and you have people that attend different events. So this is just a really simplified version, hopefully to break down a traditional, well-known platform and how you can deconstruct this. If you want to build your own social network, using graph databases. All of the big companies, LinkedIn, Facebook, they all have their own, Pinterest, they all have their own graph database underneath. What Tigergraph allows you to do is have that power yourself. So no longer is it just, you have to have this custom graph database. You can leverage these graph databases and build your own social network of the future if you wish. So we also have, breaking this down just so you understand, we have a person. So myself, John has connections to Sam, Fred, and Jill. So you might have if you have ever wondered what the first, second, and third meant on LinkedIn, we'll break it down right now. So we have a first connection, we have a second connection. So John is not connected to Dan directly, but indirectly through Sam. So you can start to see the connections. The green that we first talked about is that first layer. This is the second layer. And if we want to go down one more, this is the third layer. So we can start to see how the interconnections between different people are. And that's just sort of a simplified version of how that's constructed. Now on the right-hand side, I have a whole list of algorithms, everything from single source to PageRank. So PageRank is what Google came out with in 2000. Don't quote me on the time. They came out with PageRank, and that's what was recommending their feed, right? So they have this graph database. Now they have PageRank on it. They're recommending what you want to see using that PageRank. So then we have, in our case, in LinkedIn, let's say we're back to our social graph. Let's say we want to feed that data into, what should you see? You could use algorithms to actually feed what you want as a user to see based off their past viewing habits or click habits or whatever you want to put as the input parameters for your algorithm. So we'll go through some other use cases. I'm assuming everyone's heard of Netflix, and Netflix isn't a customer of Tigergraph, but if they want to be, they can simply join. But yeah, so they have HBO is a customer, but this is going pretty much into the same thing we talked about with patient similarity. Now the similarity algorithm can be used for a lot of different things. In this case, Netflix, let's say we want to create that 99% match. What we were looking at is the similarity of users based off their tastes. So in this case, we have person A watched, let's see, The Dawn Wall and then A Quiet Place. Person B watched this other one and this one. Let's say person C watched The Dawn Wall and the Quiet Place and then maybe watched Lion King, right? And maybe we should recommend Lion King because these people are really similar. They watch the same stuff. They like the same genre. They're pretty similar, but they haven't watched this Lion King yet. So maybe we'll want to recommend this movie to them because they have a certain percent match based off similar people to them. So that's a little bit about how similarity algorithms are being used. They're also being used in Amazon. So if you've gone to recommendations, you can see these recommended products, and what you might be storing in your graph database at this point is, let's say a user clicks on something, a user searches on something, a user hovers over something, a user adds something to their cart. What you're doing is you're actually logging all of these different events, and then you're looking at other similar users like them. And let's say this user bought an Alexa. Maybe other users after they bought Alexa, they bought this smart light, right? So maybe we should recommend the smart lights to them because a lot of similar users that use that similar product, what we're going to do is then recommend what's going to be the best thing we should show the users that they'll spend more money on, right? We want to get them to spend more money. So we're going to look at what was the most successful path for other users to spend more money. And hopefully when we recommend the product to them, they'll actually spend it and buy that product. We've talked a little about Google, so I'm not going to go too deep into it. If you're looking at PageRank algorithm, this is how it works. But on the right-hand side, you have George Washington. Not only when you search for George Washington, it came up with a bunch of books about George Washington. People also searched for. So what are some things that person searched for based off George Washington? So in the background, I think in 2012 they came out with the blog that's called Things Not Strings. So if you want to look it up, that's literally when they declared they're doing graph in the back end. They're literally using graphs interconnecting all of the data together to give you those search results that you wanted. So when I said everybody's been using graphs but don't know it, I'm assuming most people have used Google. Most people have used LinkedIn, these social networks as well. Now, they're not only being used in sort of this social networky, these recommendation engines, but they're also being used in the energy management space or IoT space. So let's say you have a bunch of nodes on your network. In this case, we have maybe electrical boxes. We have these transformers, and then we have these power connectors, and we have all of these different devices that are making up the energy grid system. Because the graph database is an analytics engine as well, you can recalibrate your whole network in real time. So you have all of these nodes here. There's power flowing through your literal energy system. Let's say the power consumption at a certain element goes up, or maybe a substation goes down. You need to be able to dynamically reroute and reassess your network at any time. And so you're recalibrating this network in real time across all of your pieces of your energy grid system. And you're able to then have that better insight so you can actually rebalance the power grid. So there are many customers using this for energy grid system management. So that's one of the use cases, especially with green energy coming up. And the lack of even in the United States, sort of this, if you've heard of Texas, when they got some snow, the energy grid system goes down. So there's definitely some infrastructure needs, and having that data accessible and recalibrating things in real time across your energy grid system is very important. Not only are they being used in energy grid system, but then also in the supply chain world. So you have, let's say you have these suppliers and parts and features and cars. Let's say one of your suppliers goes down, something happens, maybe an earthquake or a flood or tsunami, whatever happens, and you're still on the hook to be able to produce these cars. So how can you reroute things? Maybe use a different supplier. Maybe those suppliers do certain parts, and those parts are belonging to certain pieces of in this case, the sunroof, and the sunroof goes on to this car and this car and this car. So you can see the whole supply chain and recalibrate things and see the dependencies down at the very end, right? So how can you reroute things and be able to efficiently manage your supply chain in real time, which is very important, especially in this day of age with the pandemic, right? So we also are doing a lot of things in the fraud space, entity resolution. Entity resolution can not only be in fraud, but also, I think Netflix, if you use Netflix recently, they just we're trying to track users using the same account across different things. So if you want to be able to entity resolution and looking and storing IP addresses and phone numbers, associated accounts and logins and all these different things, in the fraud world, that's important because maybe account, in this case on the right-hand side, account number 101, stolen credit card, use this phone number with this device. Now there's another phone number with that same device doing some transactions with this person on the left-hand side. So maybe we're going to score this person, this transaction as a higher one to investigate. So it was flagged. So you can start to use this entity resolution and interconnecting data to be able to put priority levels on some of the data that you might want to look at. This is I guess we do have some more slides on the machine learning case. So you've probably all received scam calls, right? I'm assuming people have received these scam calls. And so on the right-hand side, we have these bad phones and we have the good phones. So we're looking at the patterns themselves to determine whether they're a bad phone. So a bad phone has an empty stable group. What that means is that you're not calling, like this bad phone is not just simply calling mom, grandma, dad all the time. There's not a stable group or your friends. On the right-hand side, you have many rejected calls. So you have a lot of calls going out. People are rejecting them. You have no callbacks. So even though you called out, no one's calling you back. And then you also have short call durations, right? So this is a pattern that they're using to determine what a bad phone is. On the right-hand side, you have the inverse of that, which is a stable group. You have a lot of people that you call back and forth. You have many people that call in a group connection. So like you call your mom calls your grandma calls your sister. You have this interconnected group, and then your call duration and the number of calls between different phones is a lot higher than on the right side with the bad phone. So you're using these patterns, and these patterns can also be features for your machine learning model, right? So traditionally, you have your data features. You feed that in your machine learning model, you make a prediction. Now you have the ability to have the features be patterns. So you have these patterns, and these patterns can be features. You have the enriched graph could be also new features. You can also, we talked about arithmetic and recalibrating and coming up with data on the fly. So one thing you might want to do, and especially from like fraud use cases, you might want to get the sum of transactions, the minimum, maximum, all of these different things, and you could feed those in real time to your model. So as well, let's get that. So this is just a little bit of use case for machine learning or for money laundering. And so you're looking at these transactions from a users to an account, to a user, to an account, to user. So you can start to look at these long loops. People are sending money, but eventually that money ends up actually back to that same user. So you're tracing that through all these different things, but the money actually comes back to the same users. You can start to see these long loops of patterns. So it's definitely being used in the machine learning space. And this is sort of pulling out a bunch of different use cases and putting together into a full system. Again, this is for a machine learning use case where they have data streaming in. Then they have some alerts. They have users taking different actions based off these alerts, and then we have the data feeding back into the graph as well. So it's sort of a perpetual feedback loop, and they're able to do this prediction in real time across the system. But again, a lot of people think lines and dots, but this is actually what the dashboard looks like, right? So you have the analytic engine underneath, but what it's powering is a traditional dashboard up top. We went over a little bit about what are graph databases, why use graph databases, and then where your provisioned box ready. It should say ready. So if you went through the steps to provision a box, you'll end up here. If you didn't come in the very beginning of this presentation, you might not be at this screen. So what you're going to do is go to https://tgcloud.io and create an account. And once you create your account, go to My Solutions and then create your solution. You just simply go through it. It's pretty self-explanatory. In our case, what we did was use the COVID-19. So simply go through this, click next, 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 and fill it out, and then you'll be at the same point as we are. So for those of you that are following along, we have the cloud portal. Our box is now ready. What we're actually going to do is click this this button right here, this action button. We're going to click Graph Studio. You'll see that all it's doing is basically bringing us to that URL that we created. So in my case, I have Herke COVID, and it's IITGcloud.io. So this is the Graph Studio. So think of this as a graphical user interface on top of the database. It helps you sort of visualize things. Of course, when I write code, I hardly use this.
Excuse me, Jonathan, sorry to interrupt, but your screen isn't visible. So if you'll just share it again.
Oh, sorry about that.
Oh, sorry.
Wonder how. Stop sharing. Okay. Sorry about that. So if you're in the cloud portal, and I'll bring this back. So if you're in this cloud portal, what you're going to want to do is click on this Graph Studio button. So click Applications, click Graph Studio, and it's going to launch your custom URL. So this is the URL that when you provisioned it, you gave it some kind of unique name. So in my case, I have Herke-COVID. Right. So you'll have your unique URL, and like I said, this is the graphical user interface to it. So it's just sort of allows you to drag and drop, click, and do all of these different things without actually having to write much code at all, unless you want to write the queries. So we're going to do this. It's all pretty much, it's actually no code. So we're going to do a full no code demo. So we have this box. If you provision your box, you're going to go into your URL. In our case, we have these two different things. We have global view, which Tigergraph allows multi-graph scenarios. So you have maybe this graph over here and you have this graph over here, and there's maybe an overlapping part of that graph. So you can have graphs of graphs of graphs, and you can have data elements that overlap. In our case, what we're going to just do is we have a single graph. So you click on this global view, and we're going to go into my graph. And so now we're in my graph. You'll see that my graph is now populated right here. We're going to go and explore these left-hand side tabs. So we have design schema. So this is how we've modeled this data. I originally created this kit when COVID came out. You know, when COVID came out and people were trying to figure out what things were, how can we address this? I wanted to try to find a solution. So I provided the solution back in like March, April of last year. And what I did was I got the South Korean, the CDC data from South Korea. And so what I wanted to do was understand the users and where the users were traveling to. And they have these things called known infections. But they also had like travel data. So I wanted to understand, did this patient travel here at the same time as another patient, even though they weren't directly shown as an infected by patient? So I was curious, and so I created this graph model to analyze that data to better understand where those connections were. So this is the design schema, and this is when you're looking at your data. You're trying to figure out how all the data is interconnected. So in this case, I have a patient. A patient has some information about them. In this case, they have like their birth year, they have their sex, their confirmed date, release date, and deceased date if they passed away, when they first had their symptoms. And so that's just some information about the patients. Then we have a geos timestamp. So I have latitude, longitude. If there's a travel event associated with that, let's say a patient traveled to the hospital, right? So it might be a travel event to the hospital. And then we have a patient edge that attends, or travels. This patient traveled to that travel event. We also have an edge between a patient where we have this infected by, so in patient, this patient infected this other patient, including some geotrees and some of the other information. But we won't dive into that. So how would you create this? I'll just show you how to, let's say you started with that blanket instead of having like the starter kit. There are a couple of different buttons up here. So we have this, this plus button. So that's how it generates this vertex. Your vertex, you can add attributes to it. So if I wanted to, give it whatever, a string of an ID, you simply do this. You can click this plus button. You create all of your different vertices. Once you create your vertices, what you want to do is create your edges, and that's this button up here. So you create the line connects to another vertex. So you can start to design this without actually having to code anything, which is pretty nice. So what I would recommend is just literally click a lot of different things. Eventually, not right now, just to learn. I'll also provide everybody with a bunch of tutorials. They can literally click through everything and have this ready to go. Now, what's really cool about this, and we'll get to it for hackathons, is that you can literally import CSV data, have your database, and then have accessible endpoints, right? So one thing that's cool about Tigergraph, it literally creates the endpoint for you. So you can have endpoints that you can call from Postman or any of your systems. And we'll get into that a little bit. So now we have our data modeled. What we're going to do is map data to graph. So let's say in this case, we'd actually had CSV files. We're not streaming data. We just simply had some CSV files of our table of data. So what that might look like is we just click on this add button. We can add these data elements. Let's see if I can actually click into some of these so you can see what they look like. So here's some files I added. I had this case ID, some city, group, infection names. I had some data around some patients. So you can see the patient had an ID number, sex, birth year, age. So these are just CSV files I added into this. I'm assuming everyone's familiar with what CSV files are. Again, no coding here in this case. I simply added a file here. That file got sort of put onto this UI portal, and then what you can do is simply click this add or map vertices, or map your data to your vertices, or map your data to your edges. And again, no code. All you have to literally do is click the data element and say, okay, this data from this CSV file actually goes to this vertex and this attribute. So you're just literally going through, adding your files here, and then mapping them. So here's that patient, and let's click on this one. So you can see the CSV file here on the left-hand side. Patient ID goes into patient ID. The global number, the birth year goes into birth year. So it's really pretty easy. You know, you have it's data files. You're literally mapping them into your database here. So now you have your data mapped. I'm going to leave this. And I just encourage everyone to explore it. I'll give, like I said, give the blog. I'll give you guys a bunch of videos, and you guys can play around and do whatever you want with it. We'll go to load data. We're just going to hit the play button. So if you're following along, go to load data, hit play. And what it's going to do is go through each of these files and then just push the data in. So you're going to see, I think this refreshes in like every 5 seconds. So you'll start to see here, some of the ones are being finished. It's going through this file, finishing this, and you can start to see some of the data is being injected into your graph here. So we have, you know, the numbers are going up. We have patients. We have 3,000 patients right now. This isn't a huge data set, but it's still pretty interesting. Once this is ready, you'll see that it'll plateau. You don't have to stay on the page after you click the play button. Now what you can do is explore your graph. This is sort of fun and interesting for you to start to see how your data is interconnected. So what I'll just do is click a patient. In this case, I left it as 5, so I got 5 patients, right? So then what you can do is, you can see that if you double click on these, you can start to see like different connections. This patient, they both live in Korea. Actually, they both live in the same province. If I double click on this one, I'm going to get a lot, so I won't double click on that one. This patient actually traveled to different places. So let's say we want to just double click and see if anyone else traveled to the same location. Anyways, so you can start to click around your data and search for different things. What I'm going to just do is change the layout to force, because it got a little messy. So you can see how these are actually connected with one another. For me, it's not that helpful, except just sort of like exploring data and thinking about how I might want to write some queries eventually. Now, again, you can get to, I'm not very good at this, but you can actually build the logical queries by using this graph patterns. So I have a blog to this of how to go through it. We're going to skip it for now for time, but simply click on this new pattern button. And without code, you can actually write your queries to it. And like I said, every query gets actually, once it's installed, it gets compiled into an endpoint. So literally the logic that you write in your database is an endpoint now that you can call from any web app or whatever you want to do. So we're going to go to write some queries. I have some queries that are already created here. So I'll show you what a query looks like. And if you're familiar with SQL, the programming language is Graph SQL. And so it's pretty readable. If you come from the SQL world, that's where I came from. And you have the select and from, and you have some, the only things that are a little bit unique here, you have a Let's start with this first one. So let's go to places. So we have infected, patient traveled, and travel time. So we have infections. So yeah, so we're literally going across an edge, and we're going to look at the T, which is the travel event, and we're selecting T. So we're selecting the travel event for this particular user. So the things that are a little different are those, this pattern here. You have these things called accumulators, and this is where you have these set of cumes, or cumes, average cumes, list of cumes, average, min, max, all these different cumes, and this is where you can do some of some of the unique calculations and things while you're traversing. So you're literally going across your data, but you're also doing an execution of these different things. In this case, we have an OR cume. It's a Boolean, true or false, right? So every time they go across, they're actually marking down that you visited this vertice. So they're doing things, and there's, it gets a little complex, but this is probably a really complex query. But when you break it down, it's not that hard to start to understand it. So as soon as you, let's see, I have to actually save this one. So I'm going to install this one. Just because what we're going to do is want to call this, and I just want to show you the endpoint, and we'll wrap that up here. Feel free to ask questions again while this installs. So it does take a second to install, because what it's doing is literally compiling it to C++. They're creating that endpoint, so then you can use Postman or your other tools or whatever you want to do to start to call this thing. That's sort of the nice part. You can have like a little simple query that takes a simple parameter that pulls out data from your database, and it's super accessible because you can call it right away. And we'll just wait for it to install. While this installs, I'll just mention this as well. So we have these hackathons that go on every month. So if you want to sort of explore Tigergraph and also be these videos, Intro to Tigergraph Cloud, Intro to PyTigergraph, Intro to Streamlit. So we're actually partnering with Streamlit. I hopefully some people are familiar with Streamlit. Raise your hands if you are. I think it's becoming a little bit more popular. Graphistry, Graph App Kit. And what you can do is jump into this challenge here if you want to be able to participate. Get familiar with Tigergraph Cloud, get familiar with the starter kits, and start to do some really fun little visualizations. And so it's just a great way to sort of learn, but you're actually participating in a challenge that hopefully you can make some money if you do win. All right, so we have this installed. Now that it's installed, I'm going to just do show the query endpoint. So this is the request. So now I have a query endpoint. I can literally call this endpoint. In this case, we're passing a parameter p, right? If we go to the top of our query, we're accepting a parameter called patient. So it's looking for a patient ID. So I have one stored right here. If you want to run this in here, you can just simply click play, right? If you want to use any of these other queries, make sure you just install them. This button right here, just install all. We just installed the one because it's a little bit faster for this. All right, so we're going to enter this patient, run the query. All right, so this might be a little bit complex. You might be like, what the heck is this? So we're looking at the subgraph of a patient here. So this is the patient that we originally looked at, this one right here. And you can see all the connections that this patient had with other patients. So in this case, I think this one's interesting right here, right? We'll do this place. This patient, so this person and this person were at the same place at the same time 3 times. But there's no connection between this person and this person as they infected one another. But there's probably a high chance that one of them came in contact with the other. In this case right here, the original patient that we searched is was known to be infected by this person. So you could start to trace this around, and that's where I was trying to understand is like, okay, well, we have these known infection paths. Is there any unknown infection paths based off where people travel to? So that's how I was using graphs in this case, trying to understand the interconnections between different data elements. With that, we're at the end of the time, so I'm going to pass it back, and thank you so much for being here.
Thank you, Mr. Jonathan. That was a great session. We do have another question by Aman Utkarsh, if you'd like to answer. can we make a dynamic database with this which manipulates with the vertices according to some algorithm we code, or with some regular new data that we feed?
Yeah, of course. Yeah, so you can write GSQL queries to manipulate your own graph. So insert new data elements, remove certain data elements. So you can use algorithms or queries to do data manipulation. You can, it's very dynamic. You can, let's say you want to add new data elements to your graph. You simply just go back to your design schema without having to lose all your data and lose your graph. You literally can append new data elements onto your graph and reinsert the connection. So when you're in production, you want to add new things. It's not like a huge change where it's like, oh, I got to bring everything down, restructure the whole database. You literally can just write this new data element to it, start to make the connections and feed that data in.
That's great. Do we have any other questions? You can write them in the chat box or in the question box.
I will say a lot of students love using Tigergraph in hackathons because they can simply create, put the data in there, start to do some queries and start to call it. And so without little effort, like we just did today, we have this whole system that was just taking CSV files, and now you have endpoints that you're calling. So it's like, you did all this stuff without having to actually do much, right? I think, a lot of people like to use it for data challenges as well. As students, I think that's important to be able to have maximum value with little effort, especially when you're trying to really get into some of these different competitions and stuff.
So, any other questions or comments or feedback? Okay, I don't think we have any other questions, so we'll be ending this talk here. Thank you, Mr. Jonathan, once again for coming. This was a great session, and the Tigergraph technology is definitely something that we're all going to try. So thank you.
All right, thank you so much. Reach to me on LinkedIn if you need to get connected or have follow-up questions.